Good afternoon and welcome. We're so excited you have joined us for ABB's webinar on energy efficient and customized solutions for moving water every day. My name is Kristen Anderson. Like I just mentioned, I'm the Marketing and Communications Manager for Drive Products at ABB here in the US, and I'll be moderating today's webinar. If you're not familiar with ABB, ABB is a global technology leader in electrification, automation, motion, and we have over 140 years of experience, 110,000 employees across the globe, and we're really excited that you're with us today. This group today that's presenting, we're all part of the motion business area, and what that means for us is this area supplies a range of electrical motors, drives, generators and services, as well as integrated digital powertrain solutions. We're able to provide our customers with energy efficient solutions, and we really pride ourselves on helping customers achieve better performance, better safety, and reliability. So I know everyone introduced themselves, but I'm joined by three phenomenal presenters who have deep domain and industry expertise in their areas. So I'm excited for you to hear from them again today. So Courtney Pickett, our Global Product Specialist for NEMA Motors, Jim Turner, Water Industry Segment Manager for Drive Products, and Vijay Anand, our Service Agreements and Digital Offering Manager for Services. So as was mentioned earlier, if you have questions, drop them in the chat as we go. I'll circle back at the end to help address any questions you may have. And with that, I'm going to pass it off to Courtney and we'll get started.
All right, hello everyone, welcome. Again, as I stated, I'm Courtney Pickett. I'm with ABB and our NEMA Motors division as a global product specialist. Today, I'm going to be walking through the energy efficient motors like our SP4 NEMA Premium Efficiency 4. And then after me, you'll hear from our drives division about how to prevent downtime in your water process. And then lastly, you will learn how to enhance your water industry efficiency with our ABB Ability Condition Monitoring service. So during this quick little time together, I will be covering the importance of energy efficient motors and why this conversation matters more than ever for water and wastewater systems. Then I'll introduce ABB's SP4 motor platform and show how it brings NEMA Premium Efficiency 4 to your everyday sloop operations. Then next, we'll look at some real world applications where you can see where these motors will make an impact and how they're designed to fit right into your existing infrastructure. And then lastly, I'll walk through some support and digital tools that ABB provides to help you evaluate your options, calculate your ROI, and make your smart, confident decisions about your motor upgrades. So let's talk about what's really driving the need for smarter motor choices. From skyrocketing electricity costs to stricter regulations and even aging infrastructure, efficiency isn't just nice to have anymore. It's becoming a necessity. So most people will assume that the biggest cost of a motor is the purchase price, but that's actually one of the smallest pieces of the puzzle. Over its lifetime, a motor's energy use can account for more than 97% of the total cost, while the maintenance and purchase, they're barely 3% combined.
Okay, it looks like we lost Courtney, so I'm going to go ahead and start sharing from my side. And Jim, do you want to get started on your stuff while we get Courtney back? Does that work?
Yep, that's fine. Let me get
Okay.
on camera here. Do you want to advance my slides, that's fine. If you can just want to stay in control.
I'll go ahead and pass it off to you. Here we go.
All right, I'm gonna gotta get to my slides here, sorry.
Oh, sorry.
Yeah, you want to advance to my presenter section?
Yes.
Appreciate it. As you're doing that, I'll go ahead and get introduced. So I'm Jim Turner. I'm in the Drives product division, and I focus as the director of our municipal water and wastewater segment. I've got 28 years experience in the segment, really concentrating on applying motor control, automation, instrumentation control to solve a lot of the common problems that you have in your facilities. Can you advance or give me control? Perfect, thanks. Hey, so what we're going to look at today is addressing common issues that cause downtime in your facilities. Water treatment plant operators, maintenance technicians, maintenance staff, all have a large challenge, which is to provide uninterrupted service to your ratepayers while maintaining tight water quality standards. Today in my presentation, you'll see how we apply variable speed drives and consulting with our knowledgeable operations and application engineers. You can rescue your plant from suffering unplanned downtime. First, let me describe what a variable speed or variable frequency drive is and where they're typically applied. The VFD is a motor control device which can be programmed and commanded to ramp up and down the speed of a pump or blower. Also, the VFD controls the speed of a pump by receiving an external field signal or through a sensor. VFDs or variable speed drives typically control the flow rate of water or chemicals, booster water pressure to maintain a predetermined set point, and provide a gentle starting and stopping flow rate for pumps that cycle on and off. So the list that you see here are really several causes of unplanned downtime, and certainly one large opportunity for energy savings by applying drives to your plants. Let's first tackle and talk about the opportunity for energy savings or chemical savings, and then move to the causes of unplanned downtime and how we solve them. You go to the next one. Oh, I can do that. I got it now. Thanks. So if Courtney would have presented first, and when she comes back on, you're going to hear that she talks about some really excellent opportunities to save energy by applying super premium efficient motors to all applications. But there's even more savings that can be found by applying VFDs to pumps and systems that rely on throttling valves to control flow and pressure. Replacing a throttling valve with a VFD can typically save enough energy to pay back that investment within about 18 months, if not sooner. We have an online calculation tool. We show a little picture of it there on the side that allows you to compare the energy spent on a throttling valve compared to a variable frequency drive application and estimate the savings over time. So the needed system parameters are horsepower of the pump, the load or runtime hours of the system, and the cost of energy. With those three elements, we can actually calculate the savings based on that load profile. And you can contact some of our water specialists to assist you both in validating the application as a good fit for variable frequency drives and making these comparisons. So there's a couple problems that we'll discuss next that are found in water treatment systems that cause downtime, and we'll talk about how to avoid them by applying variable speed drives. Those two issues are water hammer and pump cavitation. Water hammer is caused by the rapid acceleration or deceleration of fluid in a pipe. So starting a pump with maximum torque without a VFD will cause that pump or motor combination to rapidly accelerate and cause the water in the pipe to slam into the valves, the pipe joints, and rapidly pressurize the pipe run. This rapid surge in flow and pressure can damage the weak fittings, valve seals, and even rupture a pipe. You can often hear the destructive hammering noise it makes, and that's where it gets its name, water hammer. Now, if you apply a variable frequency drive to this pump, the VFD can be programmed to slowly ramp the pump up over time, maybe 20 or 30 seconds, to give a general increase in flow and pressure. The VFD can also be programmed to slow down the flow in a similar manner, eliminating water hammer for both starting and stopping the pump. Now, beyond preventing water hammer, an ABB VFD can be programmed to control multiple pumps and provide additional controls and pump protection that we have highlighted in the red text above. So let's focus on the second. Oop, went too far. Sorry about that. Let's focus on the second issue that's damaging pumps and impellers, and that's cavitation. Cavitation is caused by the inlet side or upstream side of the pump being starved for water. There may be an obstruction in the flow or a partially closed valve that creates low pressure on the pump inlet. The result is cavitation. That's a destructive force that damages the pump impeller due to erosion. You can actually audibly hear the sound of the pump change when cavitation is happening. It sounds like the pump is grinding or pumping grit or small pebbles through it. The damage to the impellers can be slow over time, or it can happen quickly, depending on the severity and the duration of cavitation. Your pumps will become inefficient or possibly inoperable, due to the prolonged cavitation. Our ABB VFD can detect cavitation. It can be programmed also to respond in a few ways depending on your application. So upon the VFD detecting the cavitation event, it can be programmed to slow down the pump and get out of cavitation. And then the VFD will slowly step the speed of the pump up slightly to return back to the commanded speed. Or the VFD can continue to run at the commanded speed and then only alert the operator to the cavitation event. It really depends on the application and the criticality to deliver water in terms of when you would choose one method or the other. So we've talked a bit about these two issues have a telltale sign. You can hear the damaging effects of both water hammer and cavitation. This issue of poor power quality is actually only noticed until the symptoms are exposed. Things like unbalanced input voltage, voltage sags, voltage dips, brownouts, etc., along with current harmonic distortion. These are the unseen and almost undetectable issues that can cause unplanned downtime. Some common symptoms are motor overheating, unexplained instrumentation malfunctions, emergency generators and other motor controls may trip offline. A site level power analysis may be needed to pinpoint or correct these power quality issues. However, one easy way to cope with this in the specific application is to apply one of our active front end variable frequency drives in the place of 6-pulse drives. This style of drive, active front end, compensates for input voltage fluctuations and doesn't create harmonic distortions like other 6-pulse drives do. Our water application experts, they can explain more about the technical details of how this technology works and how it counteracts the negative impacts of poor power quality. Another problem is, that can be avoided by education is eliminating improper installation of motors, pumps, instrumentation, motor controls like VFDs. Problems arise when you make assumptions on how to install and maintain equipment, maybe skip steps in the process or use alternative or inferior materials. Recently I was trying to wire up and install a new GFI in my house, and I skipped a step, and by not reading the instructions, I wired it wrong and it wouldn't reset. So, a taste of my own medicine there. Needed to slow down and learn what I needed to learn about how to get that GFI outlet installed properly. So, motors and couplings, they need to be aligned, lubricated to avoid unnecessary wear. VFDs and other motor controls, they need to be grounded properly. Maybe specific types of motor cables need to be used so you'll be free from nuisance trips. What we do is we publish a best practices guide on how to install VFDs correctly, proper cabling, electrical practices, grounding, bonding, things like that to meet code and offer offer a long operational life. Our water experts here can step in and help you in the planning and the designing phase of your next project, or even come out and look at existing installations that are having issues. Every water plant that I visit, and here's another big issue, it's the destructive airborne chemicals and contaminants. All those that are listed, along with maybe chlorine and so forth, all have a destructive negative impact on printed circuit boards and other critical components in your facility. These silent killers, you never know when they're going to strike. And what makes it worse is all the high humidity that you typically have in these water plants, that combined with these corrosive gases mix for a nasty, a nasty environment that you need to take countermeasures against. A lot of times it's expensive enclosures or specialty HVAC systems like scrubbers or pressurized rooms to try to eliminate or minimize the contaminant. What we do is provide conformal coatings on all of our printed circuit boards. We run tests, accelerated life and exposure test, to ensure that those coatings are applied properly and are operating correctly. And so it's always a good idea to employ protective measures, to counteract these destructive environments found in all your plants. One last thing here that I'll speak of is the larger topic of updating older systems. There's I'll say an expected useful life of different classifications of equipment. For example, pumps, motors, they may have a useful expected life of 20 to maybe 35 years, maybe longer if maintained properly. Electrical switchgear and motor control, maybe 20 to 25 years. VFDs, 12 to 18 years. Computer systems, 6 to 10 years. Your own laptop that you do your work on, has its own either useful life, obsolescence timeline, so forth. So the point here is to keep an eye on these things and make sure that you're making plans for updating and being able to stay online and provide your customers with online service all the time. Our water experts, again, they can come out and help look for updates and ways, regardless of what type of electrical or VFD system it is. As I finish, there's a good way to get in touch with us with this QR code, and just a review of the different enemies here that are always after taking you offline. Our next presenter, Vijay, you're going to love his material on the technologies and strategies for predictive maintenance for water applications. Thank you. Are we going back to Vijay, or are we going to Courtney? I'm sorry.
I'm going to jump back in real quick.
Okay, sounds good. Appreciate it. Thanks for the audible.
Sorry about that, everyone. Technical difficulties. My Zoom didn't want to Zoom. Okay, so as I was saying earlier, over the lifetime, efficiency and energy is what the most use of a motor accounts for the purchase, for the cost. And so the good news in all of this is that even a small efficiency improvement can mean big savings. That's where motors like our SP4 motor will come in, where we're offering our NEMA premium efficiency for performance, that with a potential return on investment in under a year. But of course, efficiency isn't just about being proactive. Sometimes it's about keeping up. The electricity prices are climbing, and that has a direct impact on your operational costs. So in industries like water treatment, where motors are running constantly, even a small rate hike can have a big effect. And it's not slowing down. Energy prices are forecasted to rise steadily in the coming years. And here's a fun fact. Even with our current rates, oh, that jumped a lot. So, Joy, I don't know what's happening. Okay, even with our current rates, the US only ranks 52nd in the world for electricity costs, and some countries are paying actually nearly double that. So what's the takeaway of all of this? The rising energy prices, they're not a fluke. They're part of a larger shift. Choosing energy efficient solutions now is one of the best ways to protect yourselves in the long term. So now that we've seen why efficiency matters, let's talk about how to achieve it. I'd like to introduce you to our ABB's SP4 motor platform. A lot of facilities will typically stick with the older motors because upgrades can seem risky. There's new technologies, there's retraining, compatibility concerns. It'll all feel like more trouble than it's worth. But that's exactly why we've developed the SP4. It's a drop-in, no-compromise solution built around the same AC induction motor technology that you're already using. It's a familiar, just better motor. SP4 reduces your motor losses by 20% on average with no rare earth metals, no new training, and no surprises. Just a smarter motor ready to install and start saving. And one of the biggest ways that SP4 motors deliver those savings is through the heat reduction. So one of the biggest performances killers in the motors is heat. And inefficient motors don't just waste energy, they convert it into heat, which shortens your insulation life, it wears down your bearings, and it can increase your failure risk. In this example, you'll see a motor with 93% efficiency, which means that about $70 of every $1,000 in energy is lost as heat. With the SP4 motor, this runs cooler, meaning lower internal temperatures, longer lifespan, and fewer unexpected shutdowns. And with every 10 degrees Celsius drop in temperature, this typically means there's a double installation life. So with that, we stand behind these motors with a 4-year warranty. Now, the SP4 platform is designed to meet you where you are, whatever your application looks like. We offer our general purpose motors in rolled steel with the standard and our C-face options. And then for those tougher environments, our severe duty line spans up to 300 horsepower and includes the hazardous location ratings. Both of these lines are drop-in ready for your direct online or VFD operations. And then again, no matter the configuration, every SP4 motor comes with our 4-year warranty, because performance should come with a peace of mind. So now I'm excited to introduce to you our newest addition to the SP4 family. The SP4 close couple pump motor will be launching later this year, and it's designed specifically for pump OEMs and municipal water systems. It'll be available in both our JM and JP configurations for a true drop-in compatibility. And then you get, with the NEMA Premium for efficiency performance, you won't have to redesign your system. You'll just have a smarter application-focused upgrade. So now that we've covered the SP4 platform, let's talk about where this fits, and more importantly, why it's such a great match for water and wastewater systems. When it comes to your water and wastewater operations, energy efficiency isn't just a target, it's a lifeline. Electricity can account for up to 45% of a plant's running cost. But it's not just about the cost. These are high reliability environments where downtime isn't just inconvenient, it can disrupt communities. Add to that the increasing size and complexity of plants, harsh environmental conditions, and the coordination required across multiple vendors and systems. And it's clear that motors in this space need to do a lot more than just run. So that's why ABB's focus has been on delivering motors that are efficient, reliable, scalable, and then most importantly, optimized for the real-world demands of the water segment. Now, the backbone of every water facility is the pump, and motors are what keep those pumps moving 24/7. But here's the challenge. Pumps are often oversized, the power quality can be inconsistent, and the electrical system efficiency can drop by 20% or more due to design mismatches. That's why the SP4 line supports a wide range of pump applications, from your booster stations and distribution systems to vertical lift and clarifier pumps. So whether you're dealing with mixers, aerators, or headwork grinders, the SP4 motors are available in both direct online and VSD-ready configurations, making them an easy fit for existing infrastructure and future upgrades alike. Now that you've seen the performance and applications of the SP4 motor, let's talk about the tools and support available to help you take the next step with confidence. So to support the SP4 platform, we've also launched a new energy efficiency calculator. It's a simple tool that lets you compare the energy usage and cost difference between a standard premium efficient motor and our NEMA Premium Efficiency 4 or SP4 motor. Just enter a few details about your current motor, and the calculator generates a personalized report showing your energy savings, your estimated payback period, and your CO2 reduction. It's a great way to make the business case to leadership or just to validate a decision you already know makes sense. And then for those of you that are navigating our government funding or public works requirement, it's worth noting that over 95% of our road steel motors comply with the Buy American Act. So these motors are proudly designed and manufactured right here in the US, supporting our local jobs while delivering global performance. And to quickly recap why SP4 is a standout, it's easy to choose with the reduced energy use, the longer product life, and a 4-year warranty to back it up. It's easy to retrofit with drop-in NEMA frames, American manufacturing, and products that are readily available from stock, so there's no special training or new technology required. And lastly, it's easy to save. With NEMA Premium for efficiency performance, you'll typically see under a 2-year payback time in most cases. The SP4 motors, including the new close couple pump variant, are designed to give you easy wins, the performance your system needs with the simplicity your team will appreciate. So now I'm going to pass the mic on over to Vijay and let him wrap it up. And we'll skip through Jim's presentation first.
Thank you, Courtney and Jim. Excellent information. Hello, everyone. I am Vijay Anand. I'm the offering manager for digital and service agreements representing motion services of ABB. Thanks to Courtney and Jim, we now understand how our motors and drives can help with efficiency and reduction in cost. With that in mind, I'll be touching upon how our ABB Ability powertrain platform will help address critical pain points of plant managers, that is, reliability of the entire powertrain, affecting efficiency and productivity. So what we will be seeing in this session is about lifecycle management of assets, which could be motors, drives, general machines such as pumps. And we will talk about the benefits of digital condition monitoring, a brief overview of each technology that we use, and we will also touch upon the benefits of the same. This slide talks about the value a customer or a user gets from a rotating equipment like a motor, pump, or a VFD throughout its entire lifetime. The best value is typically seen when a machine is newly installed and commissioned. Subsequently, the machine is subjected to different types of stresses affecting its performance and efficiency. We in ABB call it as team stress: thermal, electrical, ambient, and mechanical stresses. If not properly addressed, this deterioration in the health condition will cause increase in energy cost and, worst case, lead to unexpected failure, affecting production and also increasing the downtime cost. So to offset the effects of deterioration, maintenance will have to be carried out periodically, and adopting a proactive strategy such as condition monitoring can help customers see consistent values. Talking about maintenance, what type of maintenance can be done? So there are different maintenance strategies adopted by users. In general, in the water and wastewater industry, the approach varies from a high-risk run-to-failure practices to a long-term outcome-based approach. So what is the best way to do it? Very difficult to say. Regular maintenance is important to all industrial businesses, but certain strategies are more effective than others at achieving uptime. Run-to-failure can be adopted for some machines where there is redundancy, where the maintenance is not really worth. Not all machines can follow this approach. Failure of a critical machine, such as a water pump, can bring the plant to a standstill condition. Preventive maintenance is a good solution over here. Typically, preventive maintenance is time-based. However, by using condition monitoring techniques, this approach, that is a time-based approach, can be moved to more of a condition-based approach. Reliability and uptime are closely linked. A reliable piece of equipment will function at a peak performance for a much longer time. This places a growing emphasis on reliability-centered services such as condition monitoring and other planned and advisory services. Talking about maintenance again, ABB had done a survey involving more than 3,000 plant managers from over 16 countries. The aim of the survey was to identify the industry's perspective on maintenance and reliability. What came out of the survey is, aside from safety or environmental mishaps, unplanned or unscheduled downtime represents one of the costliest events in any water and wastewater industry. The survey showed that the typical cost of downtime in a water wastewater industry to be about 98,000 US dollars per hour. The survey also reveals that more than 69% of the plants or sites experienced unplanned outages at least once per month. About 8% of the plants highlighted that such outages are seen almost every day. So run-to-fail maintenance involves addressing issues only when the equipment malfunctions or breaks down. This leads to an unplanned downtime and disrupted operations, and at times it can halt the complete production. The unplanned outages that occur once a month in about 69% of the plants jump to about 80% for plants that use a run-to-fail maintenance strategy. So with this in background, we are clear that we need to use maintenance in some shape or form, maybe combine it with more scientific method of using a condition monitoring approach. Now let's briefly touch upon what is happening in the industry. So this slide talks about the digitalization roadmap for different industries. Some industries may be leading the path and some may be lagging behind. Most of the manufacturing production sectors are in the catch-up phase and moving slowly up the ladder. The undeniable fact is that all such industries are definitely moving in the path of digitalization to keep up with cutting-edge competition, increasing the efficiency of their application and also increasing the productivity. So now combining maintenance and digital can really bring in more benefits to the users. So what type of benefits can come in using industrial Internet of Things type of an approach? So the digital technology in industry is progressing in leaps and bounds. Availability and affordability of internet is one of the leading causes for development of various mobile apps and technologies based on machine learning. The industries such as water and wastewater industries are fast catching up and are looking to use IIoT-based devices to improve maintenance of drives and motors. So if this is where the water and wastewater industries are going, what can ABB offer to them to support them in this endeavor? So ABB offers to our water and wastewater customers who are looking for saving costs, run machines efficiently and reliably. The answer from ABB is the ABB Ability Digital Powertrain. So what is this offering? So this is a suite of digital services which covers the variable frequency drive, the ABB drives, the electrical motors, it can be an ABB motor or any manufactured motor, and the driven system such as the pump or a fan or gearbox. So this system helps a user to understand the health and operating condition of the entire powertrain so as to take correct maintenance decision at the correct time. How does this work? How does the digital powertrain solution work? So this slide talks about the entire schematic of the solution. It all starts from the asset that is being monitored, whether it is a drive, motor, or a general machine, which could be a pump or a fan. Connectivity devices help communicate data from these assets to a cloud environment using internet. We typically use a plug-and-play cellular option for internet, which helps us to keep away from the local customer network. The cloud is where all the intelligence is located. The data is processed in the cloud to generate KPIs that represents the health and operational parameters of the assets. Notifications would be sent to the users if any behavioral change are seen. There are three ways by which the user can view the data. One is by using a smartphone app. Number two, logging into the portal from any computer. The third one option is to use a cloud interface solution using RESTful API protocols. Typically, why would a water wastewater industry should use such application? Because they need to understand what is happening in their assets, for which they need to understand what the data is saying. What we would recommend for these customers is to provide ABB's expert access to this data so that the ABB team would be monitoring this data around the clock to let the user know when any action has to be taken. So they will provide a periodic reports providing a complete picture on all the assets condition, and they will have a periodic cadence. And if any asset is changing its behavior fast, they quickly reach out to highlight what actions has to be taken and when these actions have to be planned. Okay. With that in mind, let's briefly look into the different types of connectivity devices that we typically use under the ABB Ability Digital Powertrain System. For the ABB drives, we use a NATA 21 module, which can even connect up to 3 drives. It is a system that can help communicate all the drive-related parameters to the cloud environment. For the motors and general machines, we use a smart sensor. This is a wireless system which can be easily mounted to the surface of the asset without any need for wiring or machining activity. The third type of connectivity device is for doing an electrical signature analysis, and it focuses on the motors and the rotating machines. So using these connectivity devices that we discussed, the user can stay one step ahead with accurate information about the health, performance, and energy efficiency for taking a better decision. Now, looking into the VFD alone, let's try to understand what each technologies provide the user with the type of data that has been given. So in a VFD, using the NATA 21, all critical parameters of the drives would now be accessible remotely. Any faults would be recorded, and it will be possible to view the signal at the time of the fault for any deeper analysis. The ABB system uses an AI-based physics of model approach to estimate the remaining life of semiconductors, DC bus capacitors, and the cooling fan. When coming to the rotating equipment, such as motors and fans and pumps, what we use is the smart sensor, which is a cost-effective battery-operated device that can be retrofitted on any motor or rotating equipment. The smart sensor has the latest sensor technology, which includes 3 different accelerometers in each direction of radial, axial, and tangential. It also has magnetometer, ultrasonic microphone for assessing bearing-related condition, and true machine skin temperature measurement. Even slight anomalies in the equipment condition can be detected at a very early stage using the smart sensor solution. Also, the sensor's mechanical design allows the transducers to pick up the true machine vibration independent of any resonances that may occur. The third type of technology that we use is the electrical signature analysis, which is based on the fact that subtle changes in machine condition affects the magnetic field, which in turn affects the supply voltage and operating current. So by measuring the operating current and supply voltage using suitable clamps, it is possible to understand the health condition of a motor, and to a larger extent, the health condition of driven equipment connected to the motor can also be assessed. So this technology can be used successfully in areas where contact-based sensors may not work, such as in submersible pumps or submersible application. The measuring tools used for current and voltage clamps that can be mounted in the motor control cabinet or even in the drive. The advantage is that the clamps need not be physically sitting on the equipment being monitored, which means, as I said, submersible applications can be better monitored using the ESA technology. As a point where I would like to conclude is, we have seen from our studies that most machines that suffer from poor efficiency or fails are those on which proper maintenance related activities, whether it's preventive maintenance or condition based, have not been done. Maximum value is seen by our customers when such services are offered as an all-into bundled service agreement, which helps cost-effective maintenance in the long term, helping the users with better planning and maximizing asset performance. With that, I conclude my session, and thank you all for listening to us.
Wonderful. Thanks to all of our presenters. We are going to open up Q&A and talk through a few of the questions that were dropped in the chat. But really quick, I wanted to launch a poll here, Joy, if you could help me. We just wanted to see first if any of you folks wanted to be contacted by any one of the presenters in their business areas that they talked about: NEMA Motors, Drive Products, or Vijay from Services. So we'll leave this open for just a quick minute, and then we'll jump right into Q&A. So Joy, just let me know when you feel like it's been a good amount of time, and we can close the poll there in a minute.
Sounds good. You can go ahead and work through the Q&A, and we'll just keep that to the side.
Awesome. Okay, we saw a question come through here, Jim. This is going to be for you about how the VFD detects cavitation, and is it based off the amps of the VFD that we're seeing? And then a question following that up about selecting a VFD based on horsepower and horsepower compatibility. Can you take that?
Sure, no problem. Yeah, Cody, good question. The question is about how does the VFD actually detect the cavitation event? What it does is it is closely coupled electrically with that motor, and so when the basically vibrations of the impeller start to occur, that shows up as torque ripple and current ripple back into the electrical system for the drive. The drive then infers that type of electrical signature is cavitation, and that's then what triggers the VFD to either slow down and get out of cavitation, or continue to run and then send a bit to the SCADA system as an annunciation or an alarm. No external sensors are needed at all. Nothing in the old days. You'd have sonic sensors, microphones, different things to listen for this cavitation event. So you don't have to do that any longer with our drives. There's a second question, I think, about sizing. And so basically sizing a VFD is simply put, you need to understand what's the full load amps of the motor. The motor has a rated nameplate full load amps, and that's how we size the VFD to provide enough amps to that drive. So your voltage, and obviously 230 volt or 460 volt, and then look on the nameplate of the motor to determine and make sure that the VFD is at least that large. You asked about upsizing, or do you need to be big, much bigger than the full load amps of the motor? An example, 75 horsepower motor typically is about 90 amps. And so selecting one of our drives that's 75 horsepower is rated for 97 amps. So it gives you a little bit of headroom to control that 75 horse motor. But pay attention, in a lot of water applications, you get different funky style motors that have a horsepower rating that might be 75, but the full load amps is maybe 130 amps, because it's different. It's a multi-pole motors, multiple poles drive up the amps. So just pay attention to full load amps, and then size the drive to cover that.
Quick follow-up for that for you, Jim. The ACQ 580, is that available as a NEMA 4X?
It's available for NEMA 4X, which is an environmental rating for protecting for an outdoor and for a wet environment. Yeah, up through 30 horsepower is where we're at with our NEMA 4X ACQ 580.
Perfect. And then one here for Vijay about using ABB condition monitors to measure airflow, like in cooling towers. Is that possible?
No. So our technology measures the condition of the assets, the motors, the drives, and the pumps, but not the process-related parameters. From point of process parameter, temperature can be measured, but not the airflow.
Wonderful. Okay, and this I'm thinking is our last question here that we may have time for, just based on timing. About this, we're back to the VFDs, Jim. About can all VFDs from ABBs detect cavitation, or is this only ACQ drives? And then parameters surrounding setup in order to detect that cavitation.
Yeah, the setup is in the hardware manual. I don't know it off the top of my head. Our guys can figure that out. ACQ has the cavitation detection built in. Some of our other drives, it's purchased as a separate firmware option, but it can be applied to other drives beyond the ACQ 580 family.
Wonderful. I think there's a few more questions out here, but I think we'll wrap it up here based on timing, and we can reach out with answers when we contact you with this presentation and the recording.